Hello friends, welcome back. We are learning functions and we have seen in the last class how do we represent functions and how do we write code for that and how they are important. And also we have seen there are two different ways of representing angles and why we have two different ways of representing angles, and angles are continuous. Now today we are going to get some information about two important trigonometric functions, sin and cos functions, which are really useful methods. Let's check it out. Trigonometric functions are usually dependent on unit circles. They return values between -1 and 1, +1. So there will be a unit circle. Let me draw a unit circle. Let us take this is a unit circle. Unit circle means the circle is of radius 1 in respect to the origin. This is our xy origin where the x and y value will be 0, 0. So this is our x and this is y, and here you will be having the value 0, 0 in this place, and here the x value will be 1, and here the y value will be 1. Here the x value will be -1 and here the y value will be -1. That is the reason it is known as a unit circle. What are sin and cos functions? Okay, let me talk about sin and cos functions. If you know the angle of an object in respect to the origin, then you can find out its x position in the unit circle. Okay, x position you can find out by using cos of the angle, or you can say theta. Theta or an angle, theta means angle. You can use theta also. If you know the theta or an angle, let me give angle is good for us. If you give an angle to the cos function, it will give you the x position of an object in the unit circle. And if you want to find out the y value, then you will be using the sine of angle. If you give the angle, then it will give you the y position of the object. Let us check it out. Let us take an example that if an object is at angle 0, let me draw a table here better. I draw a table and the table is going to contain the angle. Let us take the angle of 0. Okay, that is our theta or an angle. You can say theta is equal to angle. Here you can say theta. Okay, no problem. Sine of, let us take, I can write here sine of angle. Okay, or sine of theta. If now, as I told, sine is going to give us y position. Okay, in the unit circle. Consider that. If it is 0, sine of 0 will be 0. Okay, that is the y position. If an object is in this place, let us take the object is in this place, the player or an enemy, then what is the angle of this object? That is 0, right? 0 degree or 0 radians. If I give sine 0, sine of 0 will return me 0. And what is that? Y. And you can see for this object, what will be the y position, guys? Y will be 0, right? X will be 1, y will be 0. That is its position. So you are getting the position y by using the sine function. And let us take, if an object is at angle 90 degree, pi by 2, right? Let us take the object is over here. Then what will be the y position? You can see in this place, x will be 0, y will be 1. So we are going to get 1, guys. Okay, that is, you can say that object is at y distance 1, x distance 0. You can say like that. Then let us take the object is at 180 degree pi. So sine of 180 degree is going to return me negative sine of it is going to return 0. Why? Because let us take the object is at 180 degree, okay, this place, the object will be in this place, let us take 180 degree. What is the x distance and y distance? Y distance is 0, right? Y value will be 0 here. So here x value will be -1, y value will be 0. So sine is going to return us the position of y position. So we got 0. And next let us take, it is at 270 degree. So 3 pi by 2. 270 degree means where will be the object, guys? The object will be over here. Right. And what is its y position? You can very easily say x position is 0, y position value will be 1, right? -1. So you are going to get here -1. And what will be pi? 2 pi. 2 pi means 360 degrees. So 360 degrees, sine of 360 degree will return me the value 0. And that is the y value. You can see that it is 0. 360 degree means back to the position, back to 0th position, 0th angle. That is 360 degree. You can see that you can get the y position of the object by using the angle. Similarly, you can find out the x position by using the cos function. So cos function is going to give you the x value. So here I can say cos of angle. Let's begin. Cos of 0, that means you want to find out the x position of the object at an angle 0. X position, if an object is at angle 0, its x position will be 1. You can see that x value will be 1, and that is actually x distance, you can say. Similarly, cos of 90 degree. If an object is over here, cos of 90 will be 0. If object is at 180 degree, cos of 180 degree is -1. That is x position, you can see. And cos of 3 pi by 2 or cos of 270 is going to be 0. That is our x value. You can see there 0. Okay. Then cos of 360 degree is going to be 1. Okay. You can see that is our x position, which is 1. This is how you can use the angle to find out the x and y position of the object where it will be. Let us see those things in by example here in a code. Debug.log x is equal to double quotation plus, I just get the integer values only. So I say here math f dot sine of 0th degree plus double quotation y is equal to double quotation plus integer math f dot cos of 0. So if I run this code, here I should get 1, here I should get 0. And this is actually y and this is x, right? Cos will give us x and sine will give us y. Let us save and bracket remove. Yeah, let us save and come back. And if I run the code, you can see that y is equal to 0, x is equal to 1. Is that is correct? Y is equal to 0, x is equal to 1. Let us see for next one. Let me copy this and paste it down. Let us see for pi by 2. So how do we write? Math f dot pi divided by 2. Same thing I will pass to this one. Remember that cos and sine functions are going to take radians, and we are passing here radians, not degree. Let us save and run and check, and if I run the code, you can see 1 and 0, and that is what we have found here, 1 and 0. Similarly, we can find for other functions. Copy and paste, paste and paste. So next value we are going to give here is pi, and the next value we are going to give here is 3 pi by 2. 3 multiplied by pi by 2, and the next value we are going to give here is 2 pi by 2, and here we are going to give 2 pi. Yeah, not 2 pi by 2, 2 pi. Now let us save and come back, clear this one and run the code. Let us check it out whether we get all the results properly or not. And if you see, we got first 0 1, we got 0 1, next we got 1 0, we got 1 0, next we got 0 minus 1, we got 0 minus 1, next minus 1 0, minus 1 0, next 0 1 0 1. Very interesting. Let us take an example that you have a player, and player will be having the X position and player will be having the Y position. What you do is, you are going to say equal to cos of angle. Here you say equal to sin of angle. This is going to be executed in the loop. This is executed in the loop. We put it over here, okay, this place. And this whole thing is working in a loop. Now first angle will be 0. So cos of 0 is going to be 1. That is x is equal to 1. So player dot x is going to be 1. And player dot y is sin of 0. This is 0. So the player will be in this place. Or let us take enemy. Enemy will be in this place, or player will be in this place, or any game object will be in this place, right? Then we change the angle to 90 degree. So 90 is x of cos of 90 degree is 0 and sin of 90 degree is 1. So the object will come to this place. Correct or not? X will be what? X will be 0, y will be 1. So this is the position where the object will come. Next we increase 90 degree. So 180. So what we get here, x will be minus 1 and y will be 0. So where will be the object? The object will be in this place, right? Next time we get x equal to 0, y will be minus 1. So the object will be over here. Next time the x will be 1, y will be 0. Object will come back to the same place. And if you are executing this in the loop continuously, the object will be rotating like this. Tick, 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 tick. Just you change the angle and it will rotate in a circular fashion. So if you want to rotate an object, you need to write a code like this. The object will be rotating in this fashion. Nice, right? So you can use sine wave, sine function and cos functions to rotate an object in a circular fashion. And sine wave and cos waves are used in many places. They are really useful functions, I would like to say. We will see anyhow step by step. You will get a lot of idea about how sine waves and cos waves are used in the movement of objects. Let us take an example that you want to move object in the left and right like this. Horizontally you want to move an object. You want to move the object like this. What we can write a code? The code we can write is very simple. Player dot x should be equal to sine of the angle. You pass the angle there, then what happens? You can check it out, right? And you can very easily identify in this place only. First sine 0 will be what? 0. So the player will be in this place, the object will be in this place. Sine of 90 degree, sine of 90 is what? 1. So the object will move to this side, okay? Object is moved to this side. Then sine of 180. What is sine of 180? Sine of 180 is 0. You can see that the object will come back to its place, back to this place, right? Then sine of 270. What is sine of 270? Minus 1. And you can see that object will move to left hand side, right? And what is sine of 360 degree? The value will be 0. You are applying that to x, okay? So object will come back to this place, right? And if you are doing this in the loop continuously, the object will be horizontally moving left and right, left, left, right, left, right, left, right, left, right. So you can use sine function to move an object in a horizontal way also. If you want to move object in the vertical fashion, let us take you want to move the object up and down like this. Then you can write a code like this, right? P dot y is equal to cos of angle. Simple, right? And x you do not move. X equal to 0, you have to put p dot x equal to 0 because we do not want to move in the x direction. We do not want to move in the x direction. So we set p dot x equal to 0, p dot y equal to cos of the angle. Then what you need to do, anyhow x will be 0, right, always. Cos of 0 is 1. So as cos of 0 is 1, that is why you are applying, the object will be over here, right. Then x will be 0 only, okay. Next, cos of 90 is 0, right. So you are going to get 0. 0 means the object will be over here, right. Next, cos of 180 is minus 1. So 0 minus 1. 0 minus 1 is this position. So object has come to this place. Then cos of 270 is 0. So 0, 0. The object will be back to the center. Cos of 2 pi is 1. So where the object will be? Object will go up. So if you write this code, the object will be moving up and down, up and down. This will be in the loop. And as I told, if you want to rotate the object in a circular fashion, then you are going to write the code p dot x is equal to cos of angle, right, and p dot y is equal to sine of angle. We have to write to make the object rotate in an anti-clockwise direction, right. So first, if theta is 0, then this will be 1, this will be 0. So your object will be over here, right. Then if it is pi by 2, then x will be 0 and y will be 1. So object will be over here. If it is 180 degree, cos of 180 degree will be minus 1 and sine of 180 degree will be 0. So object will be in this place. If it is a 270, cos of 270 will be 0. Cos of sine of 270 will be minus 1. So your object will be over here. Cos of 360 degree will be 1 and sine of 360 degree will be 0. So the object will be over here. And if you are doing this in the loop, the object will be rotating, right? Very nice, right? So you can move object up and down. You can move object left to left, right. You can rotate in the circular fashion. And even you can move the object in the sine wave and a cos wave format. Now we are going to draw the sine wave and the cos wave. Very easy, right? I think you know already how sine waves and cos waves work. If this is pi by 2, if this is pi, and this one is 3 pi by 2, and this one is 2 pi, and this is theta. And here you can say x is equal to sine theta, right? And this is 1 and this one is, let us take negative 1. And sine 0 is 0, we know that, and sine pi by 2 is 1 and sine pi is 0, sine 3 pi by 2 is negative 1, sine 2 pi is 0. And if you draw the graph, you are going to find something like this, right? You can move the object like this also, okay? As I told previously, the functions are useful in moving an object in some specific path. You can move the object like this. For this, you can write a code something like this. P dot x is equal to or plus equal to, you will be moving step by step 5 units. And P dot y, you can just simply say sine of the angle. And angle you have to increase step by step, okay? Angle plus plus, let us take. If you write this code, then your object will be moving like this, like this, like this, like this, continuously. I hope you guys are understanding clearly how do we write code. And cos wave we already know, right? The cos wave is simple, right? Let us take cos wave is just same as the sine wave, moved just 90 degree left. And let us take here also same thing. We will be having pi by 2, and this place is pi, and here 3 pi by 2, and here 2 pi, and here it is 1, here it is negative 1. And this is theta, and this one will be y and not x. X is equal to cos theta, x is equal to cos theta, and this one is y equal to sine theta, okay. And cos of 0 is 1, cos of pi by 2 is 0, and cos of pi is -1, cos of 3 pi by 2 is 0, and cos of 2 pi is 1. And if you draw the graph, you are going to find something like this. Okay, if you draw it properly, okay, let me draw properly. Okay, it looks like this. If you draw this side, if you start working with minus pi by 2, okay, then you will find the sine wave itself. Okay, cos theta is just moved back by pi by 2. It's the same as sine theta. Now we have got an idea. Now let us take this one is a domain and this is a range, and how do we write a code for that? Okay, let us write a code for this one and then we'll stop. Let's write a code for this. So first we create an integer array called as x, or angle you can say, is equal to, we can start storing the values. 0 is the first angle, the next angle will be math f dot pi by 2, comma, next it will be math f dot pi, right, and the next angle will be 3 math f dot pi by 2, then the next one is math f dot pi multiplied by 2, okay, 2 pi, or I can simply say here 2 pi. So this is our domain: 0, pi by 2, pi, 3 pi by 2 and 2 pi. And please remember that always sin cos or trigonometric function takes the radians and returns back radians. You people need to concentrate on converting degrees to radians and radius to degrees. Okay, next integer. This is going to give us y, and we store 0, 0, 0, 0, 0, 0. Nothing is there in this one. Then we are going to write our own function which is going to return back the value. Let us take, these are all floats, float, and this one also float, and here our function returns a float, and the function name I give my sign, and which takes the angle and returns the sine of math f, the sine of the angle, and it takes the angle, gives it to the mathematical function sine, and it will return back the value between -1 to 1 based on the angle which we have to apply to y. So first thing, we have to use a for loop. For I is equal to 0, I is less than angle dot length, which is going to be, the length is going to be 4, 1, 2, 3, 4, 5, right? Then we have to calculate the y. Y of I should be equal to my sine function, which takes our angle of I, we have to pass, and that angle will be given to this variable and it returns back the value. And after that we can say debug.log.format, and we can display x value, x equal to 0 and y equal to 1, comma, x of I, that is angle of I, comma, y of I, bracket close, semicolon. This is going to be the angle, right? So we see the angle and the corresponding y value in this place, angle of I and y. And if you remember, the angle of I are in radians, right? The angles are in radians. I want to see in degrees, so I multiply it by math f dot radians to degrees, so that we get that in the degrees. And whatever the result I am getting, I just want to get in integer. I am just converting that to integer, guys. Okay, let us save and run and check whether we get the domain 0, 90, 180, 270, 360, and the range values, the y value should be 0, 1, 0, -1 and 0. Let's come back, clear this and run and check. You can see that we got the result 0 angle, y value will be 0, you can see that. Angle 90 degree, y value will be 1. Angle 180 degree, y value will be 0. Angle 270 degree, y value will be -1. Angle 360 degree, y value will be 0. Okay guys, similarly you can do for the cos also. Okay, only stuff you need to change here is you have to change this one to cos, and this one is our cos function, my cos function, which takes the angle and returns the cos value, and we have to call here the cos function, and here we have to see the x value. Actually this is our x array, okay, x array, and here I am going to change it to x array. I think that's done. Let us save. If everything is okay, we should get the proper result. 0 angle, 1 we should get, 90 degree, 0 we should get, 180 degree, -1 we should get, 270 degree we should get 0, and 360 degree we should get 1. Let's come back over here, just clear this and run and check, and we have the result, and let's check it out. Let's compare. So angle 0 we have x equal to 1, angle 0 x equal to 1, angle 90 x equal to 0, angle 180 x is -1, angle 180 -1, angle 270 x is 0, angle 270 x is 0, angle 360 that is 2 pi x is 1. Nice, right? This is how we write our own codes, and I hope you guys have understood how do we create our own function and work with. Okay guys, for this class this much is enough. In the next class we will get some more ideas on sine wave and cos wave. So thank you guys, thank you very much, keep learning, see you in the next tutorial.